Okay, today's lesson is on writing a function rule, and it's kind of similar to what we did. You were writing function rules when you were writing equations for tables, but today's lesson is more like when we were writing expressions. Writing function rules is kind of the same idea. We're going to be writing equations. And our objective is just to write a function rule and then to use function rules to make predictions. Okay, so our first objective is just how to write a function rule. And again, this is similar to writing expressions. We have y is 5 more than the product of 6 and x. So what we're going to be writing here is an equation. And when we look for the word is, that usually means equals. So if we have y is something, it means that y equals something. So y equals, and then the remainder, 5 more than the product of 6 and x, you're just writing an expression for that side, just like you did in the writing expressions lesson. Do I have a volunteer to tell me what I would write on that side? Athena?
6x plus 5.
Good. The product of 6 and x, and it's 5 more than that. So it's 6x plus 5. So the only difference between expression, equation, is that we do have an equal sign. Okay, number 2, we have 3 less than 1/2 of x is y. There's that word is. So I know that this is going to equal y. Volunteer to tell me what the first half of that would be. Gretchen?
X over 2 minus 3.
Good. X over 2 minus 3. You could also say 1/2 x minus 3. That would mean the same thing. Okay, in number 3, we have the word is at the beginning. C is the quotient of a squared. It's not a squared, it's a squared, and 9. So C is, how would I write the other side? That I can't do right now. Anyone want to volunteer to tell me what to put on the other side? Need an expression for the quotient of a squared and 9. Gabby, you want to try it?
A squared over 9.
Just a squared over 9. Good. A squared over 9. Okay, number 4, we have F is the difference of 6 and the product of D and E. So again, we have this word is, so F equals. Now we need to write an expression for the difference of 6 and the product of D and E. Athena?
F equals D, E, and 6.
Not quite. You've got the subtraction right, you have the product of D and E right, but when it's saying the difference of 6 and the product of D and E, we actually want to start with the 6. Okay, so we want to have 6 minus D, E. Okay, any questions about this? Okay, we're going to go on to the next part. Hang on just a second. Okay, next set of rules, we are going to look at some actual situations. So instead of just kind of random expressions, we actually have some kind of word problem looking kinds of things. Number 1 says, Trent earns a base salary of $400 a week plus an additional $15 an hour for overtime. Before we write an expression, we have to define some variables. So there are 2 things up here that we're going to use a variable for. First, Trent earns a base salary of $400 a week plus an additional $15 an hour for overtime. So the hour is going to be one of our variables because it's going to be $15 per hour. So I'm going to let H equal the hours of overtime. And it doesn't actually tell us what we're going to find, but if he's earning a base salary plus he's earning an additional $15 per hour, probably what we're going to want to know is what does he actually earn in a week. So I'm going to let his total salary be equal to S. Let S equal total salary. Okay, so then we have he earns a base salary of $400 a week plus an additional $15 per hour. And when we add those 2 things together, his base salary plus his additional overtime, that's going to equal his total salary. Okay, any questions about that? Okay, let's take a look at number 2. Any volunteers to tell me what you think the variables might be? We have the school cafeteria has 285 cartons of juice in stock. Each day, a total of 60 cartons are sold. Any ideas for at least one of the variables? Go ahead.
Use C for cartons that are sold.
Okay, well, we know that how many cartons are sold here. What would we be finding? Would it be like, would it be different than that carton sold, or would it be?
Like the total over the week.
Okay, so the total over the week that is sold, that could be one idea. Also, it's telling us how much they have currently. So what else could we figure out from this? Dan?
285 minus 60.
Okay, so we might do 285 minus 60, but
X.
60x. Okay, what would x represent?
The
The days. Can I switch that to D?
Yes.
Oh, we can keep track. So let's let D equal days. So that's good for one of the variables. And then what is that expression that she just shared with us? She said we could take 285 and we could subtract 60 times the number of days. What's that going to tell us in the end? Go ahead. Yeah, total juice cartons left. Very good. So let's still use C, like Athena has suggested, but C will represent the number of cartons that are left. Okay, now we have a plumber charges a service fee of $40 plus $25 per hour for labor. It might actually be more helpful, like we did on number 2, to just start to write the expression and then decide what it is we're trying to find in the end. Any ideas for an expression we could write for a plumber charging a service fee of $40 plus $25 per hour for labor? I'd give that a try.
40 plus 25 H equals L.
Okay, 40 plus 25H equals L. What does H represent?
The hours that you work, and L
Okay.
stands for the
Whoops. Okay, hours. Worked. Okay, and then L is going to represent,
the cost of the overall.
the total overall cost. Good. And we could look at that two ways. We could let L be the overall cost to the customer, or we could say L is the overall amount that the plumber is going to earn. So we could look at that either way. Okay, last thing we're going to talk about is using a function rule to make predictions. It says you can estimate the temperature by counting the number of chirps of the snowy tree cricket. The outdoor temperature is about 40 degrees Fahrenheit more than 1/4 the number of chirps the cricket makes in 1 minute. So it asks us what equation is a function rule that represents this situation, and then it also asks if you hear a cricket chirp 50 times in 1 minute, what is the temperature? So I'm going to pause the video for a minute. I want you guys to think about what equation you could write. So I want everybody to attempt to write an equation. You could go on and try to answer the second question as well. Okay, Katie, can you tell us what an equation would be?
40 plus 1/4.
40 plus 1/4 C equals T. Can you tell us what the C and the T represent? So C is
The number of chirps.
good, number of chirps. And what about T?
Temperature.
T equals the temperature. And this comes almost word for word. The outdoor temperature, that's our T, is equals about 40 degrees more, that means we're going to add 40, than 1/4 the number of chirps, see. So the sentence is pretty much laid out for us in that one. Okay, now if you hear a cricket chirp 50 times in 1 minute, what is the temperature? Does anyone have an answer for this? Gabby?
52.5.
Good, 52.5. We have T equals 40 plus 1/4 of 50. So T equals 40. 1/4 of 50 is 12.5. And that works out to be 52.5. So the temperature is 52.5. And let's see, we're doing, does it tell us? Yeah, degrees Fahrenheit. So degrees Fahrenheit. Okay, any questions? Okay, today's assignment is a worksheet where you're just going to practice writing these equations, and then some where you'll actually have to write the equations and make predictions.